Yeah, so this is an introduction to another simulation exercise where we're going to try to work a little on tank control the level in a tank using first an on-off controller you have to program yourself, then a PID controller algorithm that that is in this template project we are using. So you should just have a look at it and find out how it works. This is a rudimentary or really basic PID algorithm. It's barely with bare necessity to do, let's say, PID control. Controller tuning is not the issue of this exercise, but feel free to try to do some controller tuning and calculations or whatever you want. If you feel like it, you're free to do so. Okay. So it's the exercise. Here is we have an emulator too, and this is the IDB that you can manipulate the model in, and there's also a HMI screen we can use. And here is a program exercise 03 main, we should call it. You have to program on-off controller. That's not really that hard. And then it is on-off control instance, and an instance of this control analog absolute algorithm that is already in the project. And you should also use a low pass filter that has been made programmed in another assignment, a first order exponential low pass filter, but there is also one in the template project if you don't have this filter. So there's a low pass filter or anti-aliasing filter, because the controller that we have here does not contain an anti-aliasing filter. Of course, normally we put the filter into the controller, but here we have to use a separate one. So okay, the purpose, what it is, this is not an exercise in continuous control. Correct PID controller tuning is not the objective of this exercise, but feel free to do so. Again, this is what you should do. You have to program an on-off controller, FB on-off controller, and call it in a program called the PIG exercise 03 main. Should be in here. I'm going to fix that. Yes, anti-aliasing filter, test the low-pass filter, embedded tank model, and so on, and the equipment that you would need. Here it's correct with the main. So first, program an on-off controller. It's basically the description here with inputs and outputs, the two inputs and one output, and you have to do something. Maybe you should use some constant for this maximum output and minimum output in your program, in your function block, and so on. Make an instance, download it, and do the connection here. These here I can zoom a little on this. These are let's say tags. They're already in this PLC IO tag table, and the simulator is giving you these signals. There's level switch high and level switch low, and you're going to try to keep the level between these two levels here. And also the tank filling model has a tank simulator that you can manipulate. And here is something maybe how to program this stuff. This should be LSL, I think, not LSH. License over here. And this is this flow control valve 0, which is an analog output in schematic format. Yeah, and documentation is your controller, and this program exercise 03 main. I think the main is missing somewhere, but okay. The exercise 03 main is what you should use, because indicating is called a main, but okay, if you don't want to use main, don't use it. Then you have to test it, and how to test this. On-off control, any observation, how it's working, alter the damping ratio of the model. We're going to go back to the model later. On your own words, always write what you're observing. And this is what happens. Why is it happening? Why is it happening like this with the damping ratio when you change it, and so on. Okay. Bit controller. That's a library function. So you have to make an instance of that word, control analog. GUE, it should probably be called. Here it's correct. Okay, and use the tank filling. But now we have an analog input, the tank level as an analog reading, and also the controller output is the same, but now it's used by the controller. how to test it, and now is this program exercise main out, the printouts that we want from this one. This is the program. Then we do the testing. Then you have to make a trace to. This is the input in 100%, this control output in 0 to 100%, and this is the set point to 0 to 100%. We're working percent there. On a normal controller that you use, of course, this analog set point that you would get from an HMI system should be in engineering units. 0 to 20 cubic meters or 0 to 100. For a tank, maybe it should be a 0 to 100%. Yeah, and how to adjust it, how you should do this. Remember how alter the set point, and what you're basically going to adjust the control here. Have to adjust the controller a little and try to have it somewhat stable or controlling too. Answer question in own words and print out a screenshot of this trace that you have for the control and show that it's halfway working. Next one is an anti-alias filter. We have to put in a low-pass filter in between here. So it has been programmed on another of these simulation exercises, the first one actually, but there is also 2 low-pass filters in here. I think maybe we are going to use the first of the Butterworth low-pass filter here, which is in the template project. But you could just as well use the filter from assignment 2. And you have to connect it like this. And of course, there's no tag connection here between the filter, because now the filter would have to get this raw value, because they're not scaled. This low-pass filter works with any value, but then you would have to convert it, like indicated over here. So you get an integer value in this tag, and maybe you would have to convert it, or maybe you should convert it. This is pretty implicit, this conversion, but we use explicit casting if you can. And this is the program. How did you program? This is basically how you can do it, or this are suggested. Other ways of doing it too. Test the filter and how to do it. And you should record then a little more in your trace. Maybe you should take a copy of the trace and make a new one, so you have 2 traces, one for this PID control and another trace then for this with the filter. Yeah, and again, this is not an exercise in filtering and computing parameters for the filter or cutoff frequency, but if you want to, feel free to do so again. Information. The tank's emulator has this instance data block that you can find in the project. Here, so it's a second order system too on top of this. So it has a damping ratio or a natural frequency. It is omega 0 and the zeta that you have integrated gain. So if you want the tank to fill fast or slow, just alter this value. It's a gain of the tank. The lower the number, the slower the tank is going to be filled. Basically, you're making a bigger tank, and the flow into the tank you're not altering. The smaller the value, the faster it's going to be. So here is a reset value for the tank if you have problems. Yeah, you have to enable tank emulation, but here is a tank initial value of a tank. Here is this, and then you have to activate this one, and then this 50% is transferred to the value. Full value is 101%. A noise trigger, how often should you change the tank noise or the splashing in the tank or whatever, and amplitude or splashing in the tank, and here's if you have automatic consumption, you have a trigger there too. Yeah, and the program, how to control it, is the X1 is the control value, and you get back the Y1 for process tank level is the process value, and you can have the consumption. We are not using that, but if you use some feed-forward control and you had a flow valve or something, you did some cascade control, you could use it if you wanted to. But we are just going single loop control here with a PID controller, and so on. And here as well, what you can adjust. I talked a little about that, but you can read this. And here is this interface. Here is an interface to the PID controller, the on-off controller I don't have in here. And here is what you can manipulate. Here's the control value 0 to full open valve, and here's the consumption. You can have automatic consumption and so on. If you don't enable the tank here, nothing is going to happen in the model. It doesn't do anything. Here are the level switches. You can't set the level switches here. You have to do that in the instance data block. But here is the set tank level, right 50 here, and set tank level is going to go immediately to 50%. So if your control is off, you can keep 50% and start back. You just jump back to 50%, because then your controller too is going to be a little off. And here's the explanation for all the buttons in the model. So, okay, this was an introduction to this control analog exercise. So what we looked at here was there are 3 assignments, a little programming. You have to program yourself an on-off controller. And then you have to use a PID controller, control analog absolute, is in the template project. And then you have to insert a low-pass filter. Here we're going to first order Butterworth low-pass filter, but you could use others an exponential low-pass filter in there too. And it's not filter and controller tuning that is the objective, but you can play around with it and do a little tuning on this if you want to. So there's not a lot of programming in here, but look into, let's say this PID control algorithm is in the project. You can look into it and find out what it is doing. How is this algorithm working? Go through it. It's documented in the system. So that was the assignment here, and documentation in your own words. Write in your own words. And if you copy it from someone else, at least understand what's going on, because that might come in handy at a later time in the course or later in your life.